Good morning all of you, and here is a nice problem from calculus. Let L belongs to natural number and all these AI's are real such that the given condition is satisfied. Prove that the function is at least 1 0 in the interval. Okay, so let's quickly solve this. If I assume a new function f of x which is antiderivative of this, because that's how we apply mean value theorem. So let's say if I define a new function to be k equals 1 to n ak by 4k plus 1. Now antiderivative of cos of alpha x will be sin alpha x by alpha, so that will be sine of 4k plus 1 times x, right, for x belonging to r. The motivation is, if we open this and see a term, let's say a1 cos 5x we are getting. Okay, so by differentiating a1 by sine, a1 by 5 sine 5x, we'll get this term. So that's the motivation. Now let's apply Rolle's theorem on this. So I know this function f is continuous in 0 to pi by 2. Okay, it's differentiable in open interval 0 to pi by 2. And now what about the values of the function? We can clearly check f of 0 equals 0 because x0 will simply make it die. This entire term will die and f0 is 0. Next is f of pi by 2. Now it's not hard to see. F of pi by 2 will be ak by 4k plus 1 and sine 4k plus 1 pi by 2. Now this quantity is always going to be 1. You can check for k equals 1. Sine 5 pi by 2 is 2 pi plus pi by 2. Put k equals to 9 pi plus pi by 2. So it's basically sine of 2k pi plus pi by 2, which is nothing but sine of pi by 2 goes to 1. So, and this quantity by the condition of the problem is 0. Hence, this function f of x is continuous in 0 to pi by 2 and differentiable. So, there exists at least one value between 0 to pi by 2 where its derivative will die. So, f dash c will be 0. It means there is at least one root of this function. Hope you enjoyed it.